information system. And so we collected a number of these. I'm only going to talk about one of them today, which is very influential it gives you a great idea of the potential of energy informatics. And that is Telenor, Norway's major telecommunications provider. And they were able to reduce their electricity usage from 300 kilowatt hours to 100 kilowatt hours per square metre, a very dramatic reduction in energy use. There were something like 1,100 workplaces that were controlled. And essentially what they did was measure whether or not someone was in a workplace, one bit of information, and use that to regulate the supply of warm air, and maybe occasionally cold air in Norway. But they had built a system that dramatically reduced their energy consumption. And we found a whole pile of these different examples that indicated to us that something was happening. We had done some prior work for the Advanced Practices Council, which is an offshoot of the Society for Information Management, the major professional organisation in the United States. So we approached them and said, we'd like to come and talk to you about Green IS. We think this is an important area for CIOs because this group consists of about 35 CIOs of many major American companies that let us come and talk to you about what we think is Green IS and how you might prepare for that. So we gave a talk in Philadelphia in October 2008, and we've been working on this for about 6 months, putting together our ideas. And when I walked to the front of the audience to start the presentation, this inspiration came to me. And I wrote on the whiteboard, energy plus information is less energy, and the role of the CIO is to put information into the energy equation. And that immediately resonated with them. They liked what we were talking about. They understood its importance. And so that's how we came up with the name Energy Informatics. We obtained additional funding for them. And we went back to Chicago, in this case, in May in 2009. And we presented our thoughts on energy informatics. And by that stage, we had developed the framework by looking at the various examples that we had seen and developing a generalized model of the sorts of things that were happening in each of the circumstances that we could see. The framework we were able to gradually adjust over time so that it fitted all of the examples that we had. And this became the core of the paper that we published in MIS Quarterly and introduced the notion of energy informatics as a subfield of information systems, an applied field designed to develop applicable knowledge. We didn't want people to develop more theory in this area. We wanted them to develop applications that would solve the problem, as we saw with a couple of the PhD presentations earlier. We are fortunate as well in that we live near Atlanta. It's about 100 kilometres away from Athens, Georgia, which is the headquarters of UPS. UPS is run by engineers, and they are sustainability conscious. They want to be highly energy efficient because it reduces their cost. And we were able to team up with some executives there to write a case study on their telematics project. They were in the midst of developing this. They had a skunk group working out of a depot in Atlanta that was building software and then testing it, building it and testing it. This was a group of engineers that collectively had about 100 years of experience with UPS. So they built this system. It was based upon two pieces of technology. One of them is the Automotive Bus. This is a communications bus that has been in most vehicles for about the last 30 years. It connects together all of the electronic devices that you have and also collects data. Around about 200 vehicle-related data elements are collected every few seconds. The other piece of technology that UPS has is something called the Diad, which is that brown box you can see at the bottom. And that's used when you get a delivery from UPS. They record, or you sign for that delivery. Both of these devices have GPS capabilities and a universal timestamp. So from the two pieces of data, they're able to pull them together. Now, in the case of the Automotive Bus, UPS developed their own technology, which they install in all of their trucks. And on any route, they collect 4,000 to 5,000 points of data, which integrate the information about the delivery and the state of the truck. This gives them a view of what happens when the driver leaves the depot. They were blind before this. They didn't know what happened. There's a lot of data collected. I'm just going to present to you the main benefits to UPS, and these flow on to the environment as well. First of all, they can play back to any driver the route that they followed the previous day. And one of the things they want to do is reduce reversing. When a truck reverses, it triples the likelihood of an accident. Accidents cause congestion and all sorts of other problems. So they were able to increase safety. They were able to reduce fuel consumption by developing more efficient routes, advising drivers on how to travel their route more efficiently. All of this was data that they got every day from every truck. And then finally, they discovered that an idling engine not only wastes fuel, but also increases more wear and tear on the engine. So they introduced a no idling policy. They trained their drivers so that the last thing they do when they get in a truck is to turn on the engine. And the first thing they do before they hop out and make a delivery is to turn off the engine. They reduced idling time by about 15 minutes in the Atlanta area. In some parts of the US, they went up to 45 minutes. And this is all important for saving energy. And then the other financial gain is that now they had the status of many of the components in a truck. They could move from time-based maintenance, such as replacing the oil filter every 25,000 kilometres, to condition-based maintenance. So they would have data telling them the state of the oil filter, and then they could make that decision as to when to replace it. So this meant less waste in landfills and so forth. So these were significant gains for UPS. In some cases, we could get figures, and others we couldn't because they considered this proprietary and competitive information. What we learned here, after a bit of a struggle, was to recognise that you have multiple energy informatics systems operating in an organisation. And so they had this new one called telematics, and so we could fit that into our model, only after realising that they also have a parallel package flow system, which is the one with that brown box, the dyad that I showed you, and that every organisation has a number of flow systems, and they need an equivalent energy informatics management system for each of those, and they need to tie these together. So that helped us to validate our model in the sense that now we could see how it would fit together in an organisation like UPS. We also visited FritoLay, which is a company that makes potato chips. Maybe you call them crisps in Denmark. I'm not certain what they're called in China, but they make potato and corn chips. And this company has a reputation for being environmentally responsible. So we went and visited them and made a tour of the factory. It was an interesting place because one of the things that we learned is that they have a team culture, and they have a team of about 7 or 8 people who run a shift in the factory. And they run them on the weekend without any managerial presence at all. Every team has a planet member. This is the person responsible for environmental issues and ensuring that they consider the planet in the decisions that they make. And people rotate through this position. So it's a very good way of making people aware of sustainability issues, in particular for FritoLay. We also realised that there are more energy flows than we thought of initially. For example, in this company, they use compressed air, and that was another energy flow that they had to manage. And they developed a way of detecting leaks, training people to listen for leaks and then how to repair them. But also there was a flow of potatoes from the very point where they were dumped in a hopper outside the factory as they flowed through various stages of being washed and peeled and cooked and all of that. And then there was a flow of corn as well. So this opened up our ideas to the fact that there are many energy flows in an organisation, and often we focus only on the main one, electricity maybe and water, but there are a lot of others to consider, and they had to make a number of changes to make the flow of corn more energy efficient. So that was the first stage when we built our model. Soon after that, I was invited to speak at the beginning or foundation of the Strategic Technology Management Institute, developed by the National University of Singapore. And I had long relationship with NUS, and they said they'd set up this new institute. Would I come and talk about sustainability? So I proposed an information strategy for sustainability, and I'll just give you a few points from this as part of my voyage to learn about energy informatics. First of all, I think it's important to recognise that we are a society that's very much in need of a transformation to a sustainable society, an energy efficient society, one based upon renewables. If you look at the components of our non-sustainable society that I've shown in a diagrammatic form on the left side, not all of those are amenable to change. The political system is very much set. Unless we have revolutions, we are stuck with the sort of governance that we have in each of our countries. And the global economy is very much a free market economy. We believe or practice that markets are the way to efficiently allocate resources. And that's pretty common across the globe. It's not totally that way, but I don't think it's likely to change. So the blue elements on the right side are the things that we can change. And the engine for change in our society is organisations. But they are responsive to technology. They are always trying to increase their efficiency and effectiveness. So if a technology comes along that's cheaper for generating electricity, for example, then they will adopt it. And we see that now with the shift to renewables because solar and wind are the cheapest forms of electricity. The other thing is organisations respond to people. They are trying to sell us things that we will purchase. The strategy of an organisation has to be built around what people will buy. So organisations are our innovation engine, but they're driven by developments in technology and by changes in people's needs and wants and preferences. So we have to think about people as one way of changing the system. And people behave in two ways. There's a yin and yang to us. We are rational on one side. This is the utilitarian consumer. This is the foundation of much of traditional economics. On the other side, we're social. We're influenced by our family, by our culture, by our peers. We imitate others. We particularly follow opinion leaders. We're very influenced by brands because of their status and prestige and reputation. And this is behavioural economics. So any decisions that we make need to take account of both of the rational and social side of humans. The foundation of most of our decisions is information. Now, if we look at this, there are two ways in which we're influenced when we're making decisions: by prices or by perceptions. If you are dealing with commodities like electricity or gold, then prices are the things that matter. You're not going to pay more for a piece of gold because it's got a brand on it, embossed upon it, than a plain piece of gold. It's prices that matter for commodities. And this is where market efficiency operates. We really need to have good information about the alternatives offered, the quality of those alternatives, and the extent to which they're substitutable. And that's the case with commodities. So therefore, prices are the piece of information that determine decisions there. On the other side, with products and services, it's all about perceptions. And this is where marketing is effective. Good marketing changes your perception of a product. So for example, if this shirt I'm wearing today had a person playing polo on it, I probably would have paid 3 times as much for it for essentially the same shirt, but I'm paying for that perception that I would look better or sound better when I've got a polo playing person on my shirt. And so these are the two aspects of information that we need to consider when we are trying to persuade people to make decisions that are environmentally responsible. So we published this in Communications with the ACM. And also at this stage, I'm fairly ambitious at times. I suggested we should have a World Sustainability Organisation, and that actually Singapore would be a good home for this. But we do need somebody that looks at designing and managing the world sensor network. We need to police what's happening. We need to verify treaty compliance. We need to resolve disputes. We have a World Telecommunications Union. We have a World Trade Organization. Nothing is really more important than the environment. And we don't have a World Sustainability Organization to manage the environment and ensure that the various treaties are obeyed and that we can resolve disputes in that area. So I even went to the point of designing a nice logo for them. Nothing has happened, unfortunately, but maybe in the future we will see this. The important message on strategy is that we create tomorrow by what we consume today. And what we consume today is determined by information. Prices, and in the case of prices, we need to align sustainability goals with prices. And this is why things like carbon taxes are very important. Without carbon taxes, we have externalities that don't get into the price of the products. And therefore, we don't have sustainability and markets aligned. If we align the two, which we're getting to now with electricity prices, then we're going to act in favour of sustainability when people make decisions about prices. And then on the other side, we need to ensure that people's preferences are informed by the sustainability actions of the companies from whom they purchase products and the characteristics of the products that they purchase. So this is very much an information decision and an information strategy that we need. The other thing that I'm doing in scanning is continually looking at what CEOs are saying. And so CocaCola is another company based in Atlanta. And here's a quote from Muhtar Kent, who calls himself the Chief Sustainability Officer of the Coca-Cola company. He says this is so important, he doesn't delegate it to anybody else. He's since been replaced by someone else. This is in 2010. And he said sustainability is the core to our business continuity and survival. And we had a number of CEOs around this period making similar sorts of statements. So another thing that we recognized was that there is a change underway in the dominant logics that guide the behavior of companies. And I'm not going to go through this whole diagram. You can find it in a paper that we published at ISIS, and I can send it to you. But over time, the key question that managers have to address changes. We've gone from how to survive when we were hunters and gatherers and early farmers, and then on how to farm. These days, we're concerned with how to reduce our environmental impact. And this is evident in the ESG movement that's emerged in the last couple of years. We wrote this about nearly 10 years ago. Things were just happening. At that stage, people were very much focused on customer service as their dominant logic. What's interesting from an information systems perspective is how the key information systems that exist in an era are very much determined by this key question and the dominant logics associated with it. And so now we're interested in things like sensor networks. The earlier talk from Nicholas, you heard about digital twins. We're interested in things like optimization and design of cradle to cradle type business models. But the shift in dominant logics is there. In the next phase, Marika and I are going to go back and look at letters to the shareholders to see when this emerges. We tried this earlier and it wasn't there, but now I think very much you'll see the focus of the dominant logic in many organizations is how to reduce environmental impact. So let's look at the acceptance of energy informatics. I did an Ngram using Google's Ngram viewer on books published up to 2019. And you can see that the word energy informatics in 3 different forms, it's not possible to combine them into one form without a bit more work. But you can see it's taken off. It's still growing a little bit, but there's acceptance of this term in the literature, and particularly when people like Bo rename their centre, it really gives us some impetus to get energy informatics established as a key thought idea. We also looked at energy informatics in article titles, and I've shown here when we published our article in MIS Quarterly, you see a bit of an uptake then, and then you can see the Energy Informatics journal comes out. Suddenly there's a lot more articles. Not a huge uptake. And in fact, in some ways, it's pretty disappointing. I wrote an opinion piece in the Journal of AIS a couple of years ago, where we questioned the lack of interest in energy informatics and associated problems by people in the IS field. And we offer some explanations for that. But it is disappointing when you look at what's happened. There have been a number of new journals and communities, in particular Energy Informatics has given us a focus. But you can see there are other journals that have started interest in this area, such as Sustainable Computing, and importantly, the Energy Informatics.Academy. So we've actually done a lot of groundwork to create this new field. There have been many special issues, and I've been involved in a number of these. I was involved in the MIS quarterly one. We got 3 papers we could publish. The JAIS one, we got 1 paper we could publish. Our colleagues are not particularly interested in this problem. There are other motivators, and the case for getting tenure in a US university doesn't include the social value of your research. It's all about the number of hits that you can get in a journal, and the easiest path forward is not to do problems, apparently, that are related to creating applicable knowledge for solving the world's most important problem. And that, I think, is pretty damning for a field that could make a large difference. More recently, there's been greater interest. I've been asked by AIS to push further on sustainability, but I think we're a decade late. And also there have been special issues here on energy informatics or smart energy that you can see. So I recently was involved with one in BiISC. We got 2 articles that we could publish. This is the most important problem facing the world. But we are not doing enough in that area. MIS Quarterly Executive, as part of this initiative to get more papers published on sustainability and energy efficiency, has agreed that I will be an SC, and in future we will publish 1 article every quarter on sustainability, starting in this September. I think I have the first article there. These will be applicable knowledge. They will be designed to help CIOs and C-level executives make better decisions about energy efficiency and sustainability. So we're getting some foothold, but as I said earlier, I think we're a decade late if we're really trying to make an impact. But sometimes you're delighted. So here's a study that was done by some scholars in Switzerland, and they developed some technology to measure how much water and energy you are using when you're having a shower. They sent us one version of this, which Marique installed in her home because she has a teenage daughter and she wants to change her behavior. And they say it was inspired by our article and the ideas that we presented there. So some disappointment, but some delight as well to see that things are happening. And as you can see from the figures here, this has an impact. So in conclusion, we've established energy informatics as a discipline. We've got courses. I teach a course in energy informatics every semester. Last year, I taught it 3 times. The demand is tremendous. I have 40 seats. I always overfill the course at 45, and I have a wait list. I get students from all across campus interested in the area. We have professorships in some universities, some labelled energy informatics, some others sort of in the same area. We have conferences such as this one, which is a real landmark for us in moving forward. We have a journal, and we have associated journals that deal with the problem, and we have academies. Energy informatics is arguably the most important theme in information systems. Energy underlies every aspect of our life. Energy determines the cost of the products and services that we consume. And the way in which energy is generated determines the state of our future society. So I applaud everybody involved in creating this conference, particularly the doctoral students who are going to undertake the research that will create knowledge that will help us solve this problem and move us forward in creating a sustainable society. And I thank Bo and Zeng very much for the opportunity to talk to you today about how we got started in energy informatics and some of the things that have happened along the way that have influenced our thinking. Thank you very much, and I will take any questions that you might have.
Yes, thank you. Maybe I can start since I have no one's raised your hands. Actually, I'm happy to to welcome you here. And I think it's very important point because for our experience, no matter about energy informatics, the center or the journal and also the conference, we also participate several of like this dark energy informatics. One thing actually for my experience is that we try to, energy informatics actually is like cross-disciplinary research. But however, we still seeing majority of researchers, they just from one specific domain, especially from electrical engineering or from computer science. It's not because I'm not saying they, it shouldn't be, but I'm just saying is the focus of this information systems or information maybe is kind of still missing. So do you have any kinds of suggestion or based on your experience, how we can create this kind of a synergy among the relevant disciplines?
Yeah, that's an important question. And I think each field has its own focus on what it thinks is a contribution. When we started this, Marique and I went to the engineering faculty, which is at the other end of campus, and started to meet weekly with some of them there and got involved in writing articles for building science journals and things like that, because they're far more concerned with solving problems than the IS field is. And I think we've decided we are about generating theory. My argument is that theory is not an end. It's a means to solving a problem. And we've lost sight of that. Now, there is a social responsibility movement in management, which IS is sort of a subfield, though it's also a subfield of computer science, that's arguing for people to